स्टूडेंट एडवांस्ड एनालिटिकल केमिस्ट्री 7 कोर्स में फर्स्ट लेक्चर जो हम स्टार्ट करने जा रहे हैं दिस इज़ अबाउट कंडक्टोमेट्री एंड we have only two topics, mainly the two topics in this course, which is conductometry and potentiometry. And the first step we will discuss about conductometry, its principles, and then its procedures and then its applications. So first I will tell you about the conductometry. Before going into conductometry, let's discuss about the electrochemical methods. What are the electrochemical methods? I think we have already discussed about this in the previous course of electroanalytical chemistry, but here I will repeat again for your reference just to go forward. Electrochemical methods are actually analytical techniques that use a measurement of a potential, charge or current to determine an analyte concentration or to characterize an analyte chemical techniques. These methods are divided into 5 main groups. Number 1 is potentiometry, number 2 is voltmetry, number 3 is coulometry, number 4 is conductometry, and dielectrometry. Few of these techniques, these methods we have already discussed in the previous course of electroanalytical chemistry, but we will discuss here about conductometry and potentiometry. Let's see the introduction about conductometric analysis. This is actually conductometric analysis is based on the measurement of the electrical conductivity of the solution, which arises due to the mobility of cations and anions towards their respective electrodes, like negative ions towards the negative and positive ions towards their respective electrodes. Electrical conductivity is entirely due to the movement of these ions. The more number of ions, the more faster the movements of ions, the more electrical conductivity we will experience in the electrolytic solution. The ability of any ion to transport charges will depend on the mobility of the ion. The mobility of an ion is affected by some factors such as number of ions, charge of ions, size of ions, and temperature. The more the number of ions, the more will be the electrical conductivity. The more the charge carried by the ions, the more will be electrical conductivity. Size of ions is smaller, then more electrical conductivity. Similarly, the more temperature will increase the kinetic energy of the ions, and so there will be effect on the electrical conductivity. The principle of conductance, let's discuss here in this slide. We will see based on the conductance of electrical current through electrolytic solution, similar to the metallic conductors, the conductivity is produced. The electrical conductance is in accordance with the Ohms Law, which tells us that the strength of current passing through the conductor is directly proportional to the potential difference and inversely proportional to the resistance. The relation is I is equal to V over R, where I is the strength of current, V is potential difference, and R is the resistance. So if we see the definitions, the Ohm's law states that according to this law, the strength of current I which flows through a conductor is directly proportional to the potential difference E applied across the conductor, whereas it is inversely proportional to the resistance R of the conductor. So the relation will become I is equal to E over R. So it means more the potential difference, more will be the strength of current. Similarly, more the resistance, less will be the strength of current. So the conductance is actually the ease with which the current flows through the conductor. So we can see here that the conductance is actually reciprocal to the resistance, because conductance is the ease with which the with which the current flows through the conductor, whereas the resistance is actually the power of resistance which is caused by the material to stop the uh, movement of the current or flow of the current through the conductor. So we can say that the conductance is reciprocal to the resistance. So C is equal to I over R. Similarly, here we have, and now we are just defining some relations and some terms, some important terms which we will use further in the conductometry. So next term is specific resistance, rho. Specific resistance is the resistance offered by a substance of 1 centimeter length and 1 square centimeter surface area. The unit of the measurement of specific resistance is ohm centimeter. Specific conductivity kV is the conductivity offered by the substance of 1 centimeter length and 1 square centimeter surface area. So we will see here the specific conductivity is actually the reciprocal of specific resistance. So we have just used the same unit as in the specific resistance, but because this is the reciprocal of that, so we have just reciprocated the already existing unit for specific resistance. So that was ohms, and we have just reciprocated that unit, and this is mhos. And because this is inverse of the specific resistance, so we would use here per centimeter. So the unit is mhos per centimeter. Next, we have equivalent conductance lambda V. This is the conductivity of the solution containing equivalent weight of the solute between electrodes which are 1 centimeter apart and 1 square centimeter surface area. The unit of measurement for this for equivalent conductivity is mhos per centimeter. So these are some basic terms, basic definitions, and basic relations which we will further discuss in the second lecture about the conductometry. So